Okay, now for the fifth question, which is for collagens, but inelastic collagen. I will solve it in details. Maybe you will see it long, but I make it like this to explain and discuss everything in it. Okay, we have a truck and a car. The mass of the truck M1 initially is 3,200 kilograms. The mass of the car is 1,400 kilograms. And the velocity of this truck initially is 5 meters per second to west direction. Okay? And the velocity for the second object, which is the car, is 7 meters per second north. So we have both of them in moving in two dimensions. Okay, they collide, then they stick together, and as expected, they will move as total mass finally, which is the both of masses, and final velocity for both of them. They will move in just one track for both of them. Okay, we need to find everything and unknown. The most thing we need to find it is the velocity, the angle, okay, the final velocity, the final momentum, and so on. Because here we have two dimensions, then we have and the momentum is a vector quantity, then we have two components, one in x direction and the other is in y direction. Now the total mass after the collision will be 4,600 kilograms. It's okay. Now this collision is inelastic. That means the momentum is conserved before and final the collision, but the kinetic energy is not conserved. Okay, that means we will not solve anything with kinetic energy, but we will solve the momentum. For the momentum initially is equal to momentum finally as vectors. The initial momentum is the momentum for the both bodies, which is the truck M1 or P1, because this is the first object, this is the second object, is equal to the total momentum finally as vectors. So because they are vectors, we have x motion and y motion. We will discuss each of them alone. Okay, now let us first see. Look here, please. For the truck, we have the mass of the truck is 3,200 kilograms, and the velocity is -5 in x direction because it goes to the west. To the west, I give it negative sign. The magnitude is 5 in x direction, plus 0 in y direction because it has not any component in y direction, so it is 0. In this case, we will compute two momentums, momentum in x direction and momentum in y direction. The momentum in x direction, it is simply the mass multiplied by that velocity in that direction. The mass is 3,200. The velocity in that direction is -5. So the momentum for the truck in x direction is -16,000 kilograms meters per second. Okay, and the momentum in y direction for the truck is the mass multiplied by its velocity in y direction. It will be 0. So the initial momentum for the truck is equal to px in x direction plus p y in y direction for the truck, which is negative 16,000 plus 0 in y direction. This is the initial momentum for the truck. What about the car? It is the same way, but we need to know the velocity for it. The velocity is 0 in x direction plus 7 in y direction, in the positive y direction, which is the north. And it has no any component in x direction, so its velocity in x direction is 0, this car. The mass is 1400 kilograms. Simply now, the momentum in x direction for the car is equal to mass multiplied by the velocity in x direction, which is 0. And the momentum in y direction, it is the mass multiplied by the velocity in y direction. It will be 9,000 or 9,800 kilograms meter per second. So the final, or the initial momentum vector for the car before the collision is px x hat plus py y hat for the car, which is 0 x hat plus 9,800 in y direction, and we need to carry the units kilogram meters per second. Okay, now initially before the collision, the p initially, the momentum initially, is the first object momentum as vector plus the second object momentum as vector initially, I. We can remove this term and this term, they are zeros. So the first object, the first truck, momentum is just in x direction. We will not put the y direction, 0. It is minus 16,000 in x direction. Plus 0, we will not put it. Now we will go to the second object, the car, which has just a momentum in y direction, which is 9,800 in y direction. I will not put this one. So the initial momentum for our system is p initial as a vector is negative 16,000 in x hat plus 9,800 in y hat. This is as a vector. We can find the magnitude of this vector or the length of this vector. It is just using the Pythagorean theorem. It is bx squared plus by squared under the root. Then we can find the magnitude of this momentum. It will be equal. Again, don't forget to put the minus sign between the parentheses to square it. After square the minus sign, it will be positive. Then the final momentum for this object before the collision is 18,762.7 kilogram meter per second. This is the magnitude of the momentum for our system before the collision. Be careful, we have x component and y component for each body together. Divide your question. Now, let us go to the final values or the system after the collision. The system after the collision, they stick together, the car and the truck. They have final momentum, P final. They have final mass, which is, as we said, 46, I think. It will be all together, it is yes, it is 4,600 kilograms, the total mass. And we have, after they stick together, they move in a direction with phi over the y, the negative y, or north of the west direction. How we know that? It's logical. When we have body and another body, their components will add together in this direction. They will not go in this direction or this direction, and we can compute that at the end. Now we will use the conservation of linear momentum. We know that the P initial is equal to P final. That's mean for each component Look here. P initially in x direction is equal P finally in x direction also. P initially in x direction, we find it. This is the momentum vector. P initially in x direction is negative 16,000 is equal to the system P finally in x direction. And P initially in y, this one in y direction, which is 9,800, which is equal to the P final after the collision in y direction. So this is P final in y direction, and this is P final in x direction. They are the component. So P finally. Now we move from P initially to P finally. It is the same vector. Look, the same vector, the same momentum, because it is conserved. نعم. طيب. P final is equal to negative 16,000 x hat plus 9,800 in y hat. And the magnitude, it is the same magnitude here. Okay, now before we can't find any angles, before the angle between them is 90 degrees. Now we have just one body, all together, combine one body. Look, this is the truck, and this is the car. They come together like this and then go with each other. طيب, okay. We find the magnitude of the potential finally. How much this phi? It's simple. We can use tan inverse as we did before. Phi is equal to tan inverse Py, the y component over the x component, which it will be 31.5 degrees above the negative x-axis, or north of the west direction. Okay, I don't use the negative sign here. If I use it, it will be with respect to positive x, but I use positive. I don't use the negative sign which denote to the x negative direction. So I will put this information in the final answer, above the negative x-axis or north of the west. I find now the final momentum magnitude, the direction of that momentum. Okay, I need the velocity of that for the two bodies. To find the velocity now, I know the mass, the total mass. The velocity, look at here, because my momentum is equal to px x hat plus py y hat. This is finally after the collision, okay? I know that the momentum is equal to the mass multiplied by the velocity as vectors. Momentum is vector because the velocity is vector, okay? But the velocity in this case, I can make it vx x hat, vy y hat, and multiply m by each term. So I need to find Vx and Vy. I have many ways. I will use this one. Px is equal to the mass multiplied by the velocity in x direction. I'll take just the x direction. Px is negative 16,000. The mass is 4,600 kilograms. So the velocity in x direction is approximately negative 3.5 meters per second. Negative because it is in negative x direction. By the same way, velocity in y direction is equal to the momentum in y direction divided by the mass. It will be 2.1 approximately meters per second. Now, the velocity vector will be Vx x hat plus Vy y hat. We find them, which is equal to negative 3.5 x hat plus 2.1 y hat. How much the magnitude of the velocity? We can find it by using Pythagorean theorem. This is the velocity Vx in negative x hat, and this is Vy. I can use it. It will be, this is the resultant velocity. This is Vx and this is Vy. I can find that velocity is equal approximately 4.08, approximately 4 meters per second, by squaring Vx plus squaring Vy under the root. I'll use the negative value if I find the phi, which is the angle above the north of west, which is can be found by tan inverse of the y component over the x component of the velocity. It will be equal the same. It is the same. It should be the same because the bodies are moved in this track, and their velocity in this track. Phi is the same between when I solve phi from the momentum or from the velocity. It is 31.5 degrees north of the west. Okay, I make it long to divide it to separate components for each body, and I hope that you understand this. Thank you.